Okay, thank you. Hi, I'm Zhenwen Wang from City University of Hong Kong. I will introduce our paper on language-based photo color adjustment for graphic designs. I would like to thank my co-authors, Nanshen, Jihad, and Rinsen. Graphic design appears everywhere in our daily lives, such as posters, web pages, and advertisements. Among many design elements, photos play an important role. They are not only decorations, but also hooks to draw viewers in. When adding a photo into a design, professional designers often need to adjust the photo colors to associate with other design elements, such as the background color in the first case, the brand color of logo in the second case, and the color of some decoration shapes or title in the third case. Now imagine you're a designer and you want to recolor photo to make the design look better. And you need to select a region and color for recoloring. For example, at first time, we may choose to recolor the hair into pink. However, we may discard this change because it is not as good as we think. So we then recolor the clothes into pink. Finally, we can obtain a satisfactory result after several times of color assignment. And while there are some existing methods and commercial softwares for conducting this tedious task, users often face a dilemma between ease of use and level of controllability. To solve this problem, our goal in this work is to construct a language-based system that is user-friendly and has a broad range of expressiveness. Given an input design and with a photo and a language-based instruction, our system can automatically recolor photo following the instruction. And the language-based instruction here generally contains two parts, one for indicating where the target local regions are in the photo, and then the other for indicating where to obtain the source colors from the design elements. The most related words to our problem can be categorized into four categories. For palette-based approaches, it is not clear how to map the target color to the palette colors, and it's difficult to restrict the change to local regions. For scribble-based approaches, although they can limit color change to a local region, they may sometimes require intensive strokes to obtain good results. And as for semantic-based approach, it can only generate deterministic results that may not be the desired outcome, which weakens users' control. And lastly, for language-based approaches, they often tend to globally edit an image and may sometimes require some time to change the structure of the object. And besides, they use vague color words like the red in this red chair. And this red may not be the exactly color from the design itself. And given a design with a photo and this instruction, we want to solve two problems: predicting the source colors accurately based on multi-granularity instruction, and recoloring the specified target regions of the photo semantically and locally using the predict source colors. And to solve these two problems, we have designed two key components in our system: language-based source color prediction module and a semantic palette-based photo recoloring module. The first component aims to find the target design elements, like the title, based on the instruction, and then predict the source colors accordingly. In the second component, our module finds the target regions based on the instruction in a coarse-to-fine manner and recolor the image through layer-wise photo recoloring. And now let's see the first component. The language-based source color prediction module is a multitask module, which jointly conducts granularity recognition and source color prediction. As a graphic design usually contains diverse elements in the form of a hierarchy. For example, text elements may include title, subtitle, and some plain text. So the language instruction should also support multi-granularity for diverse expressing. For example, coarse-grained instructions may refer to multiple colors and generate multiple plausible results. And instead, a fine-grained instruction can refer to only a specific color and then generate a single result. To recognize the granularity of instruction, we use a subnet to predict the element type and color attributes in instruction. And in this example, given instructions in green, this subnet will predict its type as title and its color attribute as none because there is no color attribute in this instruction. And as for color prediction, we design an approach to obtain best colors first by voting the colors within the regions of the target elements. And before conducting the voting, we observe that elements with distinct appearances can perform very differently. For example, pixels of text-based elements such as titles and subtitles tend to be distributed in a sparse way. And pixels of field color-based elements such as background or shape are distributed in a compact way. As such, we take different actions based on the class type. We adopt max voting strategies for text-based elements and sum voting for field color-based elements. And more especially, we first predict the mask of the target elements. Then we choose different voting strategies based on the element type, which is predicted by the granularity recognition subnet. So here, the title is a text-based element, so we use a max voting to predict a series of best colors. Then we further post-process the best colors via a source color refinement to predict the final source colors with confidence scores. And here is another case in blue, as its element type shape is a field color-based element, so we use sum voting. And in addition to train our model, we propose an approach to synthesize a graphic design dataset following some basic graphic design principles and knowledge. Please refer to our paper for more details on how to synthesize such a dataset. And now let's see the second component of our system. As a perfect ground truth language-based segmentation masks are not readily available, simply relying on deep neural networks to predict the region for recoloring can generate severe artifacts. We last propose a cost-to-find method that converts the initial region mask into a refined soft semantic color layers, which leverage both semantic features and color features. So give this input, we first predict initial region mask and extract the image palette. Then we combine semantic soft segmentation and palette-based image decomposition to generate these soft semantic color layers. And we can obtain the recurrent results via layer-wise recoloring. The details of this model design can be found in our paper. And now let's look at some results. For each design case, we show the original design on the left and the recurring result on the right, with the predicted source colors and the input instruction in the below. And here are more examples. We can see that our model can follow the instruction and obtain natural and pleasing result. The designs also look more visually harmonious after the photo recoloring. As there are no existing methods that can deal with our task, we adapt two text-based image editing methods as well as a SOTA image recoloring method for graphic design in order for them to be applicable to our task. The adapted input is shown on the left of each design case. We can see that these two language-based baselines fail to produce high-quality recurrent results, and because they use vague color words, their source colors may not be accurate enough. For example, we can see in the second row, the purple color of this head is different from the background. And for the GD recolor, it can only recolor the predict regions. For example, if we give a green color in the first row, this method tends to recolor the grass instead of the roof specified by the user. And our method can do better than this baseline friendly. And here are some applications. We can recolor a design template so that users can vary. Yes. And there is an interface of our method where users can obtain the results through input an instruction and click a generate button, which is very useful quickly for brainstorm and authoring. We can recolor multiple colors, multiple photos in a design such as brochures. And for recoloring a design collection, this is a design case for banners used in online promotion, where with a single instruction, our model can recolor a design collection containing different images. And finally, our model also supports interactive design color editing. And because of limited time, I will stop here. And please scan this QR code to find our project page.